Dear Professor and faculty member, my name is Sukma.meganova Effendi. I am a doctoral student in Rajamangala University of Technology, Tanyapuri. I want to present my homework about closed loop system. A system of consists three elements, which is input, process, output, as shown in this block diagram. The signals flow from the input through the system or process and produce an output. The system is an interconnection of elements and devices for a desired purpose. Control system is an interconnection of components forming a system configuration that will provide a desired response or a system that provides an output or response for a given input. The process is a device, plan, or system under control. The input and output relationship represents the cause and effect relationship of the process. And then the control system component is an interconnection of components forming a system configuration that will provide a desired response. This is for the component. The component can be mechanical or electrical or hydraulic or pneumatic. Then make it in the mathematical model and then put in the block diagram. The input will usually be an ideal form of the output. In other words, the input is really what we want the output to be. It's the desired output. The output of the system has to be measured. In this figure, we show the system we are trying to control the plant and a sensor that measures what the control system is doing. The input to the plant is usually called control effort, and the output of the sensor is usually called the measured output, as shown in this picture. This is the general block diagram of control system. This is for closed loop control system. There is an input or reference and then close to the input transducer and then close to the comparator or summing junction. This is compared from the output sensor from the output or control variable, then compared with input, and then produce an error or actuating signal, then flows to the controller, and then from output the controller, sum with the manipulated, manipulated actually is acting subtract the controller with the controller, then flows to the process or plan and then flows to the summing junction again if there is a disturbance in here. This is the sum process and then produce an output or controlled variable. And then from the output, measure with the sensor or output transducer. This is the feedback mechanism. Then compare to the input and produce the error. Then correct the error using controller to again until shown the output again, get the output value, then feedback again to the comparator, compare with the input. The process is cycle like this more and more until the actual output same with the desired value or the output same with the input value. And then the meaning of each part in this block diagram, the input is desired response, output is actual response, control variable is the quantity or condition that is measured, and controlled normally in the output. Manipulated variable is the quantity or condition that is varied by the controller to adjust the controlled variable. Then the disturbance is signal that affect the value of the output. The controller is measuring the controlled variable and applying manipulated variable to correct deviation of the measured value from a desired value. And then the summing junction or summing point, this is to represent addition or subtraction of signals. Incoming signal, incoming signal lines either plus addition or minus subtraction sign. The output signal is shown with an outgoing arrow. There are two types of control system. The first is open loop. Open loop is any physical system which does not automatically correct the variation in its output. Or we can see in here, in the block diagram of open loop control system, there is no feedback that fed to the input. This is only the input flows to the controller, flows to the process or plant, and then produce an output. And then the example of the open loop control system, the first is electric hand dryer. The hand dryer works on electric power supply, and when we keep our hands in front of it, it will automatically dry our hands by blowing hot air, irrespective of how much our hand is dry. And then the second is washing machine. This is another example of open loop control system which we use in our daily life is a washing machine. The operation of soaking, washing, rinsing, and drying are time-based and do not depend on the cleanliness of the clothes or if the clothes are dry or not. The conventional bread toaster, another example. This is the machine runs based on the preset time period irrespective of the toasting of bread is complete or not. And then the second type of the control system is closed loop or feedback control system. This is the system in which the output has upon the input quantity. It utilizes feedback to compare the actual output to the desired output response. We can see here the block diagram is consists of the input. This is a desired output response. Then go flows to the comparison, compare from the measurement or sensor of the actual output, compare with the input or desired output, then produce an error, then flows to the controller or control effort, then flows to the process or plant, then produce an output, then from the output, measure with sensor, and then compare again with the input, produce an error, then minimize the error or correct the error, until the process and the output, the actual output is same with the desired output or same with input. In a closed loop control system, both linear and rotational motion systems are adjusted using feedback mechanism to ensure the output follows a specified reference, whether for position, speed, or torque. The example of closed loop control system, I use thermostat heater. The thermostat sends the temperature of the system and maintains the temperature. From the block diagram, we can see the input, the desired temperature set point serve as the input. This is indicating the temperature the user wants to maintain in the room. And for the output of the system, the actual temperature measured by the thermostat. And then the plan for the system is the heating system itself, which includes the heater. And then the controller, the thermostat, which continuously monitors the actual temperature and compares it to the desired set point. And then the process of thermostat system, if the actual temperature deviates from the set point, the thermostat sends a signal to the heating system to adjust the heat output accordingly. For instance, if the actual temperature is lower than the set point, the thermostat signals the heater to increase the heat output. Conversely, if the actual temperature is higher than the set point, the thermostat signals the heater to reduce the heat output. This continuous monitoring and adjustment process maintains the room temperature close to the desired set point, effectively regulating the heating system as a closed-loop control system. And then for the closed loop control for linear motion system, in the linear motion system, the objective is often to control a parameter like position, speed, or acceleration in a straight line, and closed loop control allows for precision by adjusting the actuator's input based on feedback. The position control in a linear system is common for applications like conveyor belts, elevators, and gantries. The closed-loop system takes a desired position or speed or other parameters as input and adjusts the motor or actuator, such as a linear motor or pneumatic cylinder, to move the object to the specified location. And then for the feedback mechanism, a position sensor, like a linear encoder, continuously measures the object's location. The controller compares its position or speed or other parameters with the target, producing an error signal. And for the control action, the error signal is processed by the controller, typically a PID controller. It adjusts the motor speed and direction until the object reaches the desired position or speed or other parameters. And for the disturbing handling, if disturbance like external force affect the position or speed or other parameters, the feedback loop corrects any deviation from the desired position or speed or other parameters. For the example, in a conveyor belt system, if an object needs to reach a specific location, the controller compares the actual position from the feedback sensor with the desired position. It then adjusts the motor's power to stop the object at the exact spot. And then this is for closed loop control for rotational motion system. Rotational motion systems involve rotation around an axis, and closed loop control is commonly used to manage the speed or angle of rotation, position, or torsion, critical for applications like robotic joints, DC motor, servo motor, and rotating machinery. And then in the speed and position control, closed loop control can manage both the speed, example rotation per minute, and the precise position of rotating components such as a motor shaft. Then for the feedback mechanism, A speed sensor like a tachometer or position sensor like rotary encoder measures the actual rotational output. The feedback is used to calculate the difference between the desired and actual speed or angle. For the control action, the error is fed into the controller, which adjusts the input voltage or current to the motor, thus modifying the speed or position. And for the stability and smoothness, the controllers are tuned to achieve a smooth response with minimal overshoot, and they stabilize the system even under varying loads or disturbance. And for the example, for a DC motor that needs to spin at a specific RPM, the system measures the actual RPM using a tachometer. If the actual speed differs from the desired RPM, the controller adjusts the motor input to bring it to the target. And this is the example block diagram for the linear or also rotary motion system. From this block diagram, there is a PC or laptop, there is a motion profile, programmable motion controller, there is a set point here, there is a servo amplifier, then get the output proportional current, and then close to the plant, the rotary or linear servo motor of the actuator, and then there is a rotary or linear motion for the output, and then for the feedback mechanism, use a rotary or linear encoder for position or speed or other parameter. This is the feedback, and then compare to this one. So for the step 1, a program or motion profile will be written on a PC or laptop and downloaded to the motion controller. This program will contain parameters such as speed, acceleration, deceleration, PIDs, desired position, etc. And for the step 2, based on the program parameters, the motion controller will send a plus or minus 10-volt reference signal to the servo amplifier. And then in the step 3, the servo amplifier will take the reference input signal and provide the necessary current to generate the required force from the motor to move to the desired position. And then in the step 4, the motor will move to the desired position at the programmed speed and acceleration. And then in the step 5, motor position is sent back to the controller, typically 500 times per second, to verify that the desired position has been reached and maintained. And then this picture shown in the inside in the servo amplifier. There is a position control unit, then flows to the current control unit and speed control unit, and then flows to the motor, the encoder, and then feedback. This is the closed loop feedback mechanism. This is for rotation speed detection, close to the speed control unit and current control unit, and then for the rotation angle detection, close to the feed to position control unit. This is all my explanation about PID controller. Thank you for watching.